Hello everyone. In this video we will be doing PCB design of a regulated power supply board. Regulated power supplies are essential for all electronic projects. The way regulated power supplies work is they output a desired constant voltage that is required for our electronic project. In this video, the PCB we will be designing will have three outputs. First, a constant 12 volt output, then a constant 5 volt output, and the third, a regulated variable power supply where we can set any desired voltage we want. Let's start with the designing process. First, let us gather all the components we need. For a constant 12 volt and 5 volt, we will be using 7805 and 7812 IC. And for variable power supply, we will be using LM317. All three ICs are of TO220 package. These are the output filter capacitors for all the three ICs. We also need a 100 microfarad input filter capacitor for all three ICs. Next we need some connectors to take the output voltage. So we will add a 2-pin header for each of the IC. This will be the output header for this IC. So we will add screw connectors so that we can connect any stripped wire to the screw connector and take the output. Next, each IC requires a heatsink. Usually the metallic heatsink for these ICs is about 14 mm by 21 mm. So the width has to be about 21 mm. We don't need the dimensions anymore, so let's just delete it. Let's just copy and paste this heatsink area. There will be three heatsinks for these three ICs. Heatsinks will be behind the IC. We have to adjust the ICs according to the space of the heatsink. We have to add a potentiometer and a resistor for this IC. So let's move it a little bit to the right. This potentiometer is of 3126 package. So this will be the potentiometer where we can adjust the output voltage. This is the resistor at the pin number 1, which is the adjust pin of LM317. We need one more screw connector for the input. And we will also add a DC jack so that we can plug in a DC power adapter. Let's just readjust these components a bit. Now we have all the components, let's start naming them. Let this be our 7812 IC to get a constant 12 volt output. This will be our 7805 IC where we will get a constant 5 volt output. This will be LM317 where we will get a variable output voltage. These are the 100 microfarad capacitors. I'm doing Ctrl C and Ctrl V to copy paste this. These are the small 0.1 microfarad filter capacitors. This is a 240 ohm resistor as indicated in the datasheet. This will be the 5 kilo ohm variable resistor, that is a 5 kilo ohm potentiometer. This will be our DC input. It should be at least 15 volts. This connector, let's just specify where we have to connect positive and negative. We can copy and paste this for all the outputs. Both of these will be 12 volt output headers, and this will be your 5 volt output header. Let's copy and paste this once more. This will be our variable output. Let's just write Vout. Let's also draw an arrow to indicate that it is a variable output. And let's specify here that we have to adjust this pot to get a variable output voltage. Now we have all the components, we have named them. Let's start wiring the board. The side pins of the DC jack will have a negative connection. Connect it to the negative of input header. The back pin of the DC jack will be positive. Number 1 of 7812 is the input pin, and pin number 2 is the input ground. Let's connect the capacitors to the input and output. Pin number 3 is the output pin of 7812. Connecting the output from 7812 to the output headers. Similarly, pin number 1 to the input voltage, the input filter capacitor to pin 1, and output filter capacitor to pin 3. And the center pin is the negative. And 5 volt output to the output headers. Next, negative to the variable output headers. And we'll get the variable output at pin number 2 of LM317. This is the output filter capacitor. And this is the input filter capacitor. Resistor between pin number 1, the adjust pin, and the output pin. Potentiometer between ground and the adjust pin, that is pin number 1. We have done all the wiring. Let's just rearrange some of the tracks. Moving this track a little upward, closer to the header. Rearranging these tracks. This capacitor is a bit off. And I think all is well now. Specifying that these are heatsink areas. Lastly, we have to add copper core to the ground trace. In order to identify, let's recolor the ground trace to green. So this green is now our ground trace. Let's add the copper core. And connect it to ground trace, that is our net 0. Now we have to increase the clearance between the tracks. Let's increase the clearance to 0.6 mm. And now you can see the clearance have increased between the copper core and the traces, even here. And finally, let's put a board outline to see how big is our board. Let's just put a random size and now resize it exactly. So now our final size of the board is about 83 mm in length and about 26 mm in width. This is the complete design of a regulated power supply board. Let's do a 3D visualization. At this time I'll do a full 3D visualization. So go to Tools, 3D Preview and 3D Visualization. So this is how our board will look with all the components. This is 7812, this is 7805 and this is LN317 for variable output voltage. These are the input connectors where we can connect any stripped wire to give the input from battery or a power adapter to this jack. This should be a green PBT connector, which is actually a screw connector, but I couldn't get the 3D model for it, so I just added this black connector. This is where we'll get our 5 volt output voltage. This is where we can connect jumper wires here. We'll get a variable voltage at this connector, and this potentiometer we can vary to get a variable output voltage indicated here as we adjust. And this is the screw which has to be rotated with a screwdriver to get a variable output voltage here at these connectors. And this is the complete PCB, and this is the bottom side, and you can see none of the pins are soldered. All these components are just there. So this is the complete design of the regulated power supply board. I hope you like it. Please subscribe to the channel, and I'll upload more PCB designs in the future. Thank you. See you again.